I was scrolling through my phone today when I realized that I know nothing about how wireless connections work. How is it that such complex data is transferred from the internet to my phone wirelessly and anywhere? Well, I went down a very deep rabbit hole of research, and I'm here to tell you all about it. I honestly thought it would be harder to understand than it actually was, especially because I have no formal education related to the internet or electrical devices. I am not an engineer. So, if I could understand it, I think you can too. I'm pretty confident by the end of this video, you'll leave with a solid understanding of how Wi Fi and data and the internet work. I'm going to have to start by defining some really sciencey concepts. You might already know them or you might think it's super boring, but I promise it'll be super quick and it really helps give a full understanding by the end. The rest of this video is a lot less dense. At the very core of wireless communication are the universal charged particles that make up everything around us. You might have heard that everything is made of atoms. And atoms are made of protons, electrons, and neutrons, which are all just particles with different charges. Protons have a positive charge, electrons have a negative charge, and neutrons have no charge. Just like magnets, two particles with the same charge, whether that be negative or positive, will repel, and a negatively charged particle plus a positively charged particle will attract. Now we have to talk about electric fields. An electric field is any attraction or repulsion a charged particle exerts on its environment. That being said, if you put a bunch of electrons, which are the negatively charged particles, into a conductive metal such as copper, it creates a large electrical field due to all the charges moving around. And now that becomes a magnetic field. And by the way, a conductive metal just means a metal that allows particles like electrons to freely move on it and not stick to the metal. When this large charge of electrons is supplied with an alternating electrical current, electromagnetic waves are created, which move freely through the air. An alternating electrical current just means supplied energy, which is a flow of electrons, that goes from positive to positive, and so on. So, with all the information combined, electromagnetic waves are a combination of the electric field given off by charged particles, along with the magnetic field given off by the movement of those charged particles. Now, let's apply that information to the internet. Inside every phone, there are electrons. The phone's battery supplies these electrons with an alternating electrical current, which creates that invisible electromagnetic wave. These electromagnetic waves radiate into the air and carry the entire digital world. But before we go into how these waves carry information, let's first explain Wi Fi and the internet in general. I think it's a pretty common misconception that the internet and Wi Fi are the same thing. So let me quickly explain the difference. Let's think of a backyard garden. The global collection of digital data, which is the internet, is the water. The physical wire entering your home from the street is the water pipe, and your local Wi Fi router is just simply the sprinkler attached to that water pipe. The sprinkler does not create water, it just sprays it through the air. Technically, Wi-Fi is just a local wireless connection, otherwise known as a local area network or LAN for short, that links a local device to a router. The physical connection between Wi Fi and the internet relies on two distinct components, the modem and the router. The modem acts as a translator, which converts incoming electromagnetic waves into information. The router creates a local network, assigns a unique IP address to each device, and routes information directly to the correct device using those IP addresses. You might have noticed that most routers have arms that stick up in different directions, and this is how the router sends information to specific devices. It creates an electromagnetic wave and radiates it outwards. A standard Wi-Fi router operates at frequencies of 2.4 GHz or 5 GHz, meaning it vibrates up to 5 billion times every second. There is a physical trade-off though. The 2.4 GHz, although it vibrates less times per second, it can carry information further and passes through thick walls more easily. Whereas the 5 GHz band features more information faster, but it won't reach as far and it's more highly affected by walls or blocking objects. So now we get back into those waves from before. You're probably wondering how an invisible wave carries such complex data. For this, imagine two people holding a long rope from opposite ends. If the sender whips the rope up and down, a wave travels to the receiver. By pre-arranging a code, information could be sent. In the real world, your phone whips this wave billions of times per second, which is called frequency. Basically, information is encoded through these waves in binary code. Binary code is those huge lines of zeros and ones that computers use to code information. In computers, 1 corresponds to an on state and 0 corresponds to an off state, meaning electrical switches turn on and off to create a sequence of zeros and ones, all which have unique meanings. Within electromagnetic waves, a normal wave codes for a 0 and a wave flipped upside down codes for a 1, and the receiver on your phone detects this voltage shift, decoding it into binary code. To keep these waves organized, modern routers use a technology called orthogonal frequency division multiplexing, or OFDM. I'm honestly not sure if that's the correct pronunciation, but just go with me here. Instead of sending a single massive stream of data, the router splits this stream into many tiny parallel substreams called subcarriers to prevent interference. But because airwaves are a shared resource, only one device can transmit on a specific channel at any exact microsecond. This is because when waves collide in the air, they interfere with each other and disrupt each other's sequencing. This creates the bottleneck of airtime. If a smart home bulb takes too long to send its data, it occupies a stream of data, forcing a high speed laptop to wait in line, dragging down the entire local network. This is why sometimes using the microwave will glitch your TV. It's because these devices are fighting for airtime. Although modems and routers allow for everyday wireless internet, the majority of the internet is transmitted through physical wires called fiber optic cables. These cables rest underwater on the ocean floor and are roughly the thickness of a garden hose. But these cables at their core are made of strands of pure silica glass as thin as human hair. You're probably wondering, how does glass carry the internet's information? Data is transmitted down these glass fibers as rapid pulses of laser light, using the physics of total internal reflection. Using lasers ensures that this information can travel at the speed of light, which is very quick. Remember the binary code used by electromagnetic waves? Same concept here, but with light. The light is pulsed on and off to correspond to binary code. The cable consists of an inner glass core with a high refractive index wrapped in an outer glass layer with a lower refractive index. This just means that when the laser is shot into the core at a certain angle, it reflects between the core layer and causes the light to bounce in perfect zigzag patterns inside the core for thousands of miles. To keep the signal strong, inline repeaters boost the light signal every 70 kilometers, powered by a high voltage copper sheath inside the cable. So, although it seems like a lot of the internet is wireless, at its core, it's also powered by wires. Each home Wi Fi is routed through internet lines, and each cell tower is also routed through internet lines, which all eventually converge into large data centers around the world that store and handle this information. If you see those green boxes around your neighborhood, this is where all your house's modems send your signals, which then sends them down big fiber optic wires. When a device moves out of Wi Fi range, it seamlessly switches to cellular mobile data, if you pay for data on your phone plan. Instead of connecting to a private local router, the phone connects to massive carrier cell towers. But how does data actually reach the phone without a router? It relies on continuous registration. The phone constantly whispers to the nearest tower to announce its location. So when a file or video is requested from the internet, the carrier's core network routes that traffic directly to the exact antenna where the phone is currently registered, and broadcasts the wave directly to that device. In order for cell towers to not block each other's airtime, tiny time slots are assigned to each phone. If 10,000 people are in a cell tower zone, the tower divides its low frequency wave into 10,000 microscopic packages. Unlocking those waves requires a physical security card called your SIM card, which stores unique credentials that verify the phone's identity. But how does data travel so far when Wi Fi gets affected by walls? Well, cell towers operate on a licensed frequency purchased exclusively by carriers from governments. To cover vast distances and travel through buildings and trees, cellular networks rely heavily on much lower frequencies, such as 850 MHz or 900 MHz, which is a big contrast to the 2.5 to 5 gigahertz used in home Wi-Fis. But it also means that it simply takes longer to transmit the same digital file, which is why download speeds are a lot slower on data. Having done all this research gave me a pretty big appreciation for everything that I'm able to access on my phone so quickly. The hardware and software that we've developed to be able to decode this binary code at such insane speeds, send information through invisible waves, and create cables made of glass to send information at the speed of light makes me appreciate how smart the minds who worked to invent the internet and wireless connections must have been. The modern wireless world is really just an invisible masterpiece of global engineering. But That is all for my research. I really hope this was just as interesting for you as it was for me to research, and thank you for watching.